Hi, I am Fardin Abdi from Embedded and Real-Time Systems Laboratory of Department of Computer Science of University of Illinois at Urbana-Champaign. Uh, in this video, I'm going to demonstrate the tool that we have developed in this lab for the safe distributed flocking on unreliable networks. We have implemented this algorithm on a mobile robot simulator. We use the StarlL platform, which provides a simulator capable of generating delays in the communication as well as packet drops. The StarlL is a Java-based programming library for developing mobile robotics application on Android phones. StarlL platform has been also developed in the EC department of UI/UC. I first need to mention that this algorithm is not basically simulation is not a real-time simulation, and that's why the speed of the vehicles in this algorithm is variable based on how much computation is being done, and that's why sometimes robots, as you will see now in execution, go faster and sometimes slower. So as you can see in this execution, we have 5 vehicles. The vehicle in the center is the leader, which basically is one of the vehicles who is equipped with the central coordinator and can exchange commands with the operator. So operator, when wants to give a new detour point to this whole flock, basically change the path that flock is following, will give this command to the leader, and then leader will generate the safe commands for rest of the followers and send it to them. Well, now by clicking on this screen, as you can see, this red dot that appears is the new detour point that I, as an operator, give to the flock, and then I require the leader to generate the passes for the followers and lead them towards this new waypoint. This simulator is actually simulating uh, sending packets with delays, which is why we can see the path gets moved from the original path to the final one. This happens very quickly under the normal conditions, since wireless communication happens much faster than the physical movements of a robot. The safety condition basically guarantees that if the wireless goes down at any point, the system remains collision free. I can show you an example of this happening. So as you can see right now, the wireless is performing perfectly. So when I click on a point on the screen, the robots just follow towards this path. But let's see what will happen that after the operator gives a new waypoint and the followers, or at least one of them, the wireless goes down. So I can give this one and then disconnect the wireless. Uh, what will happen is that the pass won't go fully towards the last one, and the robots will follow the last pass that they receive. Now I will execute another execution and show you like another example of this situation. So here we have the same 5 robots, leader and the followers, and giving the passes to the robots. As you can see, the new curve is being generated, and then the safe passes are being generated for the robots. Another simple pass. Yeah. So now on this left corner of the screen, I can control the wirelesses. I disconnect the wireless for robot 4, and then I click again on the screen, but now I cannot give any new waypoint because leader cannot generate this new pass given to the um, basically followers, because it cannot communicate with followers anymore. Another example of generating a pass, like, yeah, and then wireless goes down for bot 3, and as you can see, the robots don't make further progress towards the final pass. I'm going to give you another example. Uh, so far we just talked about the wireless, but there might be other problems. So in order to make progress, we need 2 conditions, as it has been mentioned in the paper. The first condition is that the wireless is working, so that actually once leader generates a new command, it can send that new commands to the followers and followers can receive them. But what's the second condition? The second condition is that leader should be able to generate a sequence of save commands for followers. So what does that mean? Let's give you an example. So in this screen, if I click somewhere very close to the current position of the followers, the curve that will be generated would be a very sharp curve. And most probably, when I generate a very sharp curve, uh, what might happen is that the safety won't be maintained if the leader decides that such a sharp curve gets taken. Therefore, the algorithm decides not to send out the next intermediate pass and chooses safety over the progress. So let's see what will happen if I click somewhere here. As you can see, this is a very sharp turn. Okay, for this one, hopefully it can generate it. But for this one, you see, it's a very sharp turn, so leader cannot generate a very um, curve that goes through this pass, and it decides to maintain safety over making progress. Another example like this one. But when I click on somewhere on the screen that we can generate passes, we'll make further progress and we'll go there. So this example shows that we need to have first a communication that is somehow reliable. I mean, if you totally lose the communication, you won't have any further progress. And second, you need to be able to generate a safe set of commands, like intermediate commands, that takes you from your current uh, set point to the next set point. Thank you very much for watching the video.